This is CyberSound, your simplified and fundamentals-focused source for all things cybersecurity.
Welcome to CyberSound. I'm your host, Jason Pufall, joined in a surprise gesture by Steve Maresca.
A surprise?
Yeah, you looked at me like, oh, look at you go today.
It's more like eyebrow greetings.
Maybe it's all my energy. I'm telling you, I'm dragging a little bit, and I come at it with gusto, right? And Brian Brehart, hey, it's nice for you to join again. I appreciate you. I appreciate you taking the time and being willing to participate.
Thanks for having me.
So we did talk on I think our last episode about the fact that we're going to have a little mini series on sort of Internet of Things, operational technology, security things that exist around that. We spent a bunch of time in a previous podcast talking about I'll call them home-related challenges, the smart home issues.
The land of broken toys.
No doubt. I think we drove that home kind of in that, maybe not exactly that language, but probably like, boy, this is all complicated stuff. But I think we want to talk a little bit more about like operational technology, probably a little bit more in the manufacturing space. We do a fair amount of work with manufacturing. I think we see a lot of kind of purpose-built technology. And it's got a whole variety of problems. I mean, I know, Steve, you mentioned, seeing mail servers on old thermostats or old temperature controllers, right?
Yeah.
I mean, these have a real wide set of challenges, but they are, unlike the home, where a lot of it's nice to haves, these are all critical things, right? They run machining, they run critical processes. They can't get away from them, and yet they have all these security challenges.
Yeah, and I'd go beyond manufacturing. I mean, some of our customer base has shipboard technology out in the middle of the ocean that is, monitoring some subsystem it's not manufacturing, but it's got the same kind of problem domain, right?
Yeah, and the criticality.
Right. And there are lots of organizations that have HVAC stuff that's monitored. They have valves that are remotely controllable, things like that. So operational technology is the Internet of Things, but more serious at the end of the day.
But more serious.
Right. There's revenue attached to it is probably the right way of thinking about it. And manufacturing is really the biggest sensitive industry, right? And I don't necessarily mean big widgets. You might be talking about water treatment plants. There have been lots of items in the news about water flow, waste treatment being attacked by adversaries in the United States. That certainly comes into play here. The bottom line is the things we're talking about, the technology we're talking about is fragile. And
yes,
what do you do about that?
So I think the one thing that jumps, as I'm thinking about the previous podcast, even the home stuff, all reasonably new. People are buying things within the last year, 2, 5, not a really long period of time. The OT space, I think one of the challenges are people might have something in production for the last 15 plus years, and it hasn't been updated. It hasn't changed at all, right?
So let's talk examples just to frame it for folks that may have this stuff and not know it. Electronically controlled valves, solenoids, temperature sensors, pumps, programmable logic controllers, microcontrollers that do some sort of automation task related to an industrial process, manufacturing line measurement equipment, anything that might be in that neighborhood, including security, locks, access controls. These are all in the domain of discrete little devices that get purchased, in 2010 and then don't get replaced until 2025 because they didn't stop working. So why bother? If there's something on the shelf, well, it was put there in inventory at the time that contract was fulfilled initially, and the same old device gets replaced with the exact set of vulnerabilities that might have been there at time of purchase.
Right. And it comes down to, they don't get replaced because they have such a critical role. Like, I used to work at a large logistics company that will go unnamed, and we had systems that controlled, moving boxes from A to B, that the hardware was at the time already 10 years old, and the operating system that supported the software we wrote, like they wouldn't, we would say, well, why don't we upgrade this box? And they'd be like, nah, we're not messing with that.
Right. I mean,
yeah, it works,
and,
but you'd be
don't
like,
touch
yeah,
it.
but
right. I've been in bowling alleys that have relay controlled equipment that is decades beyond what you would believe is a reasonable lifetime. It's not the same, but it's the same sort of.
You take a one pin drop away, and all of a sudden you win a game. That's big stuff.
I mean, it would certainly be irritating if it stopped working and I was winning.
There you go.
But is that internet connected?
No, of course not. But the point of the matter is that longevity is both a desirable issue, a desirable facet, and a problem in this area. So here's the problem. If a device has a vulnerability, how do you assess that? Well, typical IT runs some sort of a scan, measures that risk in situ. That is not a viable practice with operational technology.
Because of robustness.
Yeah, if you breathe on these pieces of equipment from a network perspective, if they are network connected at all, they will fall over. If they are not network connected, they are accessible through gateways of some kind. And we're talking about potentially inducing physical realm impacts. If you make a pump fall over, you may void a tank that is 30,000 gallons of caustic fluid on the factory floor. That is not an outcome that is tolerable. And if that line is down, we might be talking about millions of dollars of revenue and many staff, not productive. So, a strategic way of assessing this risk requires a very different practice from what is the norm. We're talking labs. We're talking isolated copies of equipment. We're talking about effectively isolated islands to compartmentalize risk.
Yeah.
And that's okay. As long as it's known, it can be controlled. I think, sorry, Brian.
I was going to say another thing that we also have to think about is a lot of these control systems, especially the ones, like you said, that have been around for 15 plus years, did not originally come out with connectivity in mind.
Right.
So you're already behind the eight ball, and then to your point, they're so fragile that, okay, so now what? And then you have to do that risk assessment. You have to say, well, it's running a lot of times they're running like a version of Linux that sometimes that distro actually doesn't exist anymore in the modern world.
Right. We're talking about 2002, 1999 era code that will never be updated. Right. And the manufacturer's out of business or something to that effect.
Yes.
So
yes,
we spent a little bit here the last couple of minutes talking about the risk with being proactive, right? With trying to assess the vulnerabilities, right? Don't run vulnerability scans because it might actually cause the devices to crash, et cetera. But they're targeted. Right. So
Absolutely.
I think there's big news events that occurred around this.
Yeah. One of the most memorable for your average person would be Stuxnet, which is many years past now, but was the targeting of Siemens programmable logic controllers that were located in many locations, but the main targets were in Iran, and it was related to uranium enrichment facilities. It was a very complex attack path. These were not directly accessible from the internet, but it enabled the destruction of equipment, and frankly, some very specific weapons research was interrupted. That is espionage. That is nation state level consideration. But I mentioned water control and water treatment. It's happening in a more domestic and mundane sphere every day. The fact is that some of this equipment is connected, whether directly or indirectly, to the internet at large, or on networks within an environment that they should not be. It's a convenience thing. It's a monitoring thing. It's done with good intentions, but if you can get to it and you're an adversary, the odds are very good that you will be able to invoke some sort of damage by interacting with it.
And I think that's a challenge here, right? 'Cause again, looking back at that podcast, we talked about home devices. We talk about the security risk, but if you're really going to stack them up against the operational tech risks, totally different. Right?
Very.
You're really talking about public health, water supplies, electrical grid, things that everybody depends on, that would be expensive if they went down, hugely disruptive if they went down. So sort of knowing that, we probably should talk a little bit about strategies, because for me, the difficulty with this conversation a little bit was, hey, these things are not that robust. It's really difficult to scan them and validate whether they're secure or not. And by the way, oftentimes they're so old, you don't have any recourse or ability to update them anyway. So what's reasonable strategy to then protect this?
Well, first, I would suggest most generally that we think of this from a audience perspective as more of a business continuity, revenue protection kind of a mentality, because the strategies that you employ to protect that type of area actually help from a security standpoint anyway.
No doubt.
Bottom line, the very first thing is please, oh please, don't connect it remotely to any sort of outside vendor to the extent that you can manage that, or to the internet at large. If you need a third-party vendor to reach this stuff, make sure it's done through protective controls like VPNs, through network segments, and all of the other typical trappings that require extreme validation of the authenticity of the other end.
So
of that
some sort of
equation.
gateway in front
Absolutely. Of it. And that gateway also translates to structurally architecting operational technology appropriately. Most vendors have some sort of a gateway that bridges between network segments, translates between protocols and things of that variety. Those are the appropriate devices to put in front of any other communications. Beyond that, if you don't have those available, isolation's the name of the game.
Okay.
Yeah. Isolation, things we did in some other companies I worked in. There was the idea of it, as things started getting connected to the internet, and we started hearing more and more about, these control systems getting attacked. There was a legit look at, okay, we need to replace this. What is that going to take? It's not as simple as, okay, isolation, but it was something that, this is our business. This is what makes us go. And so,
yeah, I mean, it's modernization is what you're talking about.
In essence.
Yeah, modernization, exactly. And one of the things that really helps, believe it or not, as I've been seeing on the YouTubes and reading, is the advent of the microcontrollers, or single board computers, like a Raspberry Pi or a Raspberry Pi Pico, where these things there's a lot of companies that are using these devices to go to these companies that have control systems and say, we can, with a reasonable amount of effort, replace your system with a modern version using this device. We've tested it here. We've tested it, and a lot of people are looking at it, such as that logistics company I work for. They were looking at building their own,
right?
Using it to build their own systems and maintain it. So you don't have to connect to a vendor, and you don't have to have a VPN. We just handle it. So those are some things that I've been experienced with.
And certainly, if you're an individual in process engineering, or if you have those folks that report to you, those individuals may not be able to customize something like a Raspberry Pi or another microcontroller, but during procurement, you can at the very least kick the tires, so to speak, test the equipment that's provided in a realistic scenario and see how resilient it is. Building that into the actual validation of the equipment while it's being evaluated for purchase is, in my opinion, a really prudent idea, because that might be the only time that you realistically have the ability to test it with rigor. It's not deployed yet. You have sample equipment. It's going to be configured in a reasonably similar way. Throw it in a lab environment and bring in security professionals to do some destructive tests. That's a practice that many organizations don't bother performing. They may have labs for testing, the processes they're about to implement, and they only go through the actual sequencing.
So I'm going to throw one more maybe wrench in this then. So how do you convince say a small manufacturing company to go through the level of effort to replace these things or upgrade these things when in their view, they probably feel like they aren't necessarily significant targets for attack. They feel like the control systems that they have are working, right? They haven't demonstrated any real problems, and it's really nothing but a potential expense to address kind of an unrealized risk, right? What's the conversation you have there? Because it's a hard one. It's easier with like an EverSource where the entire grid potentially is impacted, and they probably have a reasonable budget for that.
And they have a regulatory expectation of doing that.
Right.
Mm-hmm. This is a risk management decision. If you're talking about a CNC machine in the manufacturing sphere, it is hundreds of thousands or millions of dollars, depending upon its complexity. You're not updating that device.
Yep.
You need it to be on the network to some degree to have G code sent to it to manufacture a part.
To get its instructions.
Right. That right there, it's an unavoidable, acceptable risk just because of the revenue associated with it. That will stay static because it needs to.
And then you manage it as best you can.
You manage it as best you can. Everything else, if it's tied to revenue or tied to reputation or tied to productivity, those are the reasons where you don't want to have something fall over, and you might want to work around that from a risk perspective.
Yeah, I mean, that seems like the right answer, right? You can't ignore it. You have to at least understand what your risks are and make reasonable determination about what they're
If you're going to lose customers or lose a lot of revenue, it probably warrants some attention.
Okay.
Yeah, you run the gamut of all the risk, right? It's either risk avoidance, risk acceptance. You look at like Steven said, you look at the equipment, it's millions of dollars. Okay, we just accept that. Yeah. Or we mitigate it as best we can. But for a smaller company, they're a little more flexible. I worked for a manufacturer who made slot machines. And while we were international, we were a smaller company. I mean, I don't think we had more than 1,000 people who worked there. And most of them were game designers. So we were a little more flexible in what we could do with our manufacturing process. It wasn't unusual. I mean, to give you an idea, they went from making pinball machines to video games. And then from video games, they went to making slot machines. So they have changed the entire, or modified, I don't know. Yeah, they didn't replace it, but so they were nimble and they could do those things. And they'd done it before because they had to. Right. And they were affected by regulation. So, they would come and talk to you about manufacturing games and, how do you lock it and so as that evolved, so would the company. So it does. It's, your situation dictates. And so you just make those decisions to fit.
So take advantage of product life cycles and the changes of the business to effect change as well.
Yeah, and it's a risk. I mean, I think you're right that it's a risk discussion. But with CMMC, a lot of manufacturers now have regulatory requirements that they didn't, half dozen years ago. Mm-hmm. So we are seeing regulations creep down into smaller businesses for sure.
It's true.
These may or may not be in scope, perhaps, but it's going to be a guiding factor.
Right. If you're regulated, start there. If you're not,
right,
risk is where you begin.
That's fair. That's reasonable.
Yeah. One final one.
Yeah.
If you're a very large company, you can put in I know it's a lot of money and, it's not something you do commonly, but it's something that we had done, which was you just create a new facility with all the modern stuff, move all of your manufacturing to that, and then retrofit or upgrade the original one. And now you have both. But again, you have to have a certain amount of revenue
right,
to make that go. So, but that was the kind of company we were doing that anyway. That was part of our, business model is we would create new, because it just would grow.
Yeah. You had to evolve.
Need would grow.
Right.
Yeah.
I feel like we covered everything.
I think so.
Okay.
Don't ignore it.
Yeah.
Assess it. Think reasonably, think critically, and you can control the risk.
There you go. Summarize.
And keep up on the risks and threats that are affecting your specific area.
Absolutely.
Well, all right. So we've done a two-part. We may. I think we did talk about possibly running a discussion around the privacy risks of some of these devices, which is probably a good
That's
one.
a
We really
worthwhile subject.
yeah, heavily security based in the last couple. So I think we'll find ourselves a good privacy person to talk with about that.
I wonder who we have in mind.
Yeah, the thing is, we're finding there's more and more of them now, right? And as always, we hope people got some value out of this, learned a little bit, started to think about some of the risks perhaps within your own environments. As always, Brian, I'm going to throw this to you because you said it the first time. I still love it. What do we need people to do?
We need people to smash that like button.
We do. We do. I mean, honestly, the more you engage, the more sort of people see this, and hopefully from an education standpoint, we can get the word out better. So we appreciate everybody listening. Hope you got value, and look forward to you tuning in for the next one. Thank you.
We'd love to hear your feedback. Feel free to get in touch at Vancord on LinkedIn. And remember, stay vigilant, stay resilient. This has been CyberSound.